Okay, so here we are. We're in the beautiful offices of Abrams Design Build in Tacoma Park, Maryland. This is the meeting of the Capital Chapter Passive House Alliance for this month, and we are fortunate to have Paul Grahovac here, our panelist from Prosoco, and he will describe air sealing and water sealing products to you and the process for the proper implementation of those products. So welcome to the webinar, and let me introduce Paul.
Okay. Now speak and see what happens. Test 1, 2, 3, 4. There we go. All right, thank you for joining us. For those participating by webinar, if you have any difficulties in hearing me by way of volume or otherwise, please use the function. What is there, an email function?
The question function.
Question function, and let our moderator know. We'll see what we can do to fix that. Well, this is AIA's slide where they totally disavow any responsibility whatsoever for anything a speaker might get up here and say. Obviously, this is a presentation approved by AIA for continuing education credits. But they realize that in the process of giving these presentations, presenters are likely to have recommendations and express opinions, and they don't want to be tagged with any of that. They do have a rule about mentioning brand names. We've been giving these presentations for decades, and we follow the rule. Presentation is also approved by RCI, formerly Roofing Consultant Institute. Now they just go by RCI because those expert waterproofing consultants have come down off the roof and now are involving themselves in the overall building envelope. We'll hear more about RCI here in a minute. AIA requires us to copyright the presentation. Copies are available on request. Here are the AIA learning objectives. The first one is to consider whether job site conditions, constructability, and post-construction building performance ought to guide development of construction products. Imagine that. Then we're going to take a look at the conventional means for preparing the rough openings for window installation and the window installation itself, and seeing what that's doing for our industry. We're going to look at some newer technology for that purpose. Then we'll look at some case studies where that technology has been used in a remediation or renovation context. First, it's good to remind ourselves that denial is not just a river in Egypt. There's a study by EPA showing that about half the commercial buildings out there leak water. Now, why is this speaker talking about water to Passive House? Passive House is all about air leakage and air changes per hour. And why in the world will Passive House sponsor a speaker come in here and talk about water intrusion? Well, the short answer is if you use state-of-the-art fluid-applied waterproofing products to solve your water intrusion problems, you simultaneously solve your air leakage problem. And by the time we get to the end of the presentation, I think you'll see what I mean by that, but I didn't want to make you wait to the end, so I put together a few preliminary slides. Throughout the course of the presentation, you're going to hear me make reference to air leakage testing chambers and hurricane weather testing chambers. One of the mock-ups we put in those chambers was this sheet-applied assembly, typically used in residential construction, a lot of commercial. That's one of the mock-ups we tested, assembled in strict accordance with the manufacturer's instructions for that building wrap and peel and stick membrane. And then we do another mock-up in the fluid applied technology that we're going to be talking about during the presentation. And we put them in a test chamber. For frame of reference, I sometimes give this presentation to folks that aren't familiar with passive house, so I've got an Energy Star standard up there. 5 air changes per hour at 50 pascals equal to 20 mile an hour wind. Passive house is also at 50 pascals. You come in at 0.6 air changes per hour. Very stringent. The sheet wrap mock-up we tested came in at 7 air changes per hour. And the fluid applied came in at 0.17. That's at 50 pascals, 20 miles an hour per the ACH standard. But these are hurricane test chambers. So we turn the knob up to roughly 40 times or so. The ACH standard, about 2,900 pascals equal to 155 mile an hour wind-driven rain, because this chamber also has water. And we still came in under the passive house standard. So I'm hoping that that will cause you to want to see what the rest of these slides are all about. If you want to read about an example where the technology was used on a passive house project, you can go out on the internet, read this article about the Mini B up in Seattle, where a group of community college students who had never swung a hammer put together a small passive house with this technology and were able to meet the standard handling. Fluid applied WRVs, air barriers, and let me just talk about terminology a little bit. For many, many years, before people started being concerned about energy conservation and air leakage, the building code had within it a requirement that the sheathing backup wall be covered with a water-resistant barrier. The default in the code is what we used to call back home. I'm from Kansas, grew up in rural Kansas. We call it tar paper, asphalt impregnated building paper, felt paper. Laps are not sealed. They're just shingled, like the shingles on the roof, so if any water gets behind the cladding, siding, or brick, hits that tar paper and runs down off the sheathing wall. So when you hear people talk about a WRB, that's what they're talking about, a water-resistant barrier to meet code. We hear about 10 years ago, it was determined that, hey, in fact, I can show you a study by the National Institute of Standards and Technology dated 2005, shows that if you control the air leakage in accordance with the standards that have been accepted, you can get a 40% reduction in natural gas consumption and a 22% reduction in electricity consumption, completely independent of insulation. And so folks said, well, gee, I put a water-resistant barrier on that backup wall to meet code for water intrusion. Might I use the same system to function as an air barrier? And so that's why you often hear speakers and people involved with this refer to WRBs, water-resistant barrier, or air barrier, more or less these days talking about the same thing. I'm going to pause a little bit because we've got some folks joining us and they're welcome. We're going to get some chairs set out. No. Sorry. Yeah. I know, me too.
Well, the flyer from the National Alliance at 10, flyer that I sent out says 10:30. Were you folks here? Are you from the meetup center?
No.
Oh.
Alan had said.
Oh, Alan's, okay, great, terrific. I think we can go ahead.
All right, we're just about doubled our population here, so I'm just going to quickly run through this. The title of this presentation and a lot of the slides have to do with water intrusion. The reason Passive House has agreed to have me go around the country and get us to these chapters and these webinars is that there's a close connection between preventing water intrusion and preventing air leakage. We prepared a mock-up using typical residential construction, sheet-applied water-resistant barrier / air barrier and peel and stick membrane. And we prepared a markup using the fluid-applied technology we'll be talking about. And we put both systems in these test chambers that we'll be looking at. And for context, to give this presentation to some that are not familiar with Passive House, I've got an Energy Star number up there for 5 air changes per hour. Passive House standard at 0.6 air changes per hour, both at 50 pascals of pressure, corresponding to a 20-mile-an-hour wind. The sheet wrap we tested, and we put this together in strict accordance with the manufacturer's instructions. In fact, the manufacturer has attended several of our workshops where we actually had the test chamber and has confirmed the accuracy with which we are putting that assembly together. We tested that mock-up. We got 7 air changes per hour. On the liquid applied, we got 0.17 changes per hour. Then, as we'll see, these test chambers are used to waterproof these structures to withstand 155-mile-an-hour wind-driven rain of a Category 5 hurricane. It's about 2,900 pascals. And even at that extreme standard, the fluid-applied mock-up came in under and met the Passive House strict standard. And you can read online a little article about a small Passive House structure in Seattle that was constructed by some community college kids that had never done any construction work. They were able to satisfy the Passive House requirements. Okay, now we got everybody on the same page. For about the last 10 years, fluid applied WRBs, meaning water resistant barriers / air barriers. And by that I mean what's applied to the external face of the backup wall, commonly OSB, oriented strand board in residential, or plywood, dense glass, gyp board in commercial. For about the last 10 years, fluid applied WRBs / air barriers have been taking market share from sheet applied materials. However, these fluid applied systems are not totally fluid applied in that they require the use of fiberglass mesh tape or industrial nonwoven fabric in order to deal with the sheathing seams and the joints and seams in the rough openings where the windows and doors are placed. And even if you use these pre-made corners, and you get some idiot out there in a white dress shirt called in to do slave labor for the president of his company on his luxury home so we could get some footage and photos, and yes, that is yours truly. It makes it a little easier, but still pretty awkward, problematic to integrate that material with the liquid material. Well, there's a new sheriff in town. Liquid applied, flashing and detailing membrane. To prepare the rough opening, to install the window, and also to form the WRB / air barrier coating out on the field of the wall. It's based on something called STPE, silyl terminated polyether. This is sealant technology. Sealants in the United States means silicone sealant or urethane sealant. That's not what it means in Japan or in Europe. They gave up using silicone and urethane about 30 years ago, when silyl terminated polyether sealant was invented in Japan. It is by far now the leading construction sealant in Japan and Europe. The reason that it's in this presentation and in this technology is it has a unique capability to be engineered to spread like a coating, like that gentleman is making it do. You can't do that with a bead of silicone sealant. Now, toward the end of the presentation, we're going to get into a little more about the differences between STPE and the conventional silicone urethane sealants. But I want to throw up this table real quick and talk more about where it comes from later. Just to give you an idea of what I'm talking about, here's an expert ranking the sealants and making particular notice of the formulation versatility of the STPE, such as being able to be formulated to spread like a coating. You can hear, as your ears might be attuned to it, you may hear that STPE combines the advantages of silicone and urethane sealant. What I call the contractor in-house spreadable version has been in use since 2004. Now, what I'm talking about when I'm talking about a contractor in-house spreadable version, I'm talking about a contractor located in the Pacific Northwest and now active in the Southeast United States, who for over 2 decades has made a very good business out of being a self-performing general contractor, building repair specialist, going into structures, typically multifamily condos with OSB sheathing, going to structures like that that 7, 6, 5, 4, 3 years old, completely ensconcing them in scaffolding and shroud, removing the OSB, removing the windows, replacing the rot, and generally rebuilding the building because of water intrusion.
Well, can I ask you to pause there for a second? I just got a indication that someone cannot see the slides you're showing. And so we need to make sure your computer is set up as the panelist. So help me get back to your screen that we can, I'm going to call him.
I think we should make inquiry whether anyone else is having that problem.
Yeah. So are you set up? Which one do I want to hit? I'm sorry, I don't know. Okay, go. All right, we're all set, folks. Sorry for that confusion. I think we should have the right screen up now. Paul's going to whip through some of these slides that he just showed, but he's not going to talk you through them all. We're going to pick up where we left off.
I'm not advancing now. Here we go.
The basic intent of these slides is to show that with the, hang on a second, Paul, stop it there. With the membrane barrier applied, we had a much higher air infiltration rate. With the liquid applied barrier, it was delivering far, expectations that far exceeded those of a house wrap application. So, Paul, do you want to pick it up from there? I think those images were helpful, but you can carry on from there.
As I was saying, the contractor in-house spreadable version has been in use since 2004. And by contractor in-house spreadable, I mean a contractor in the Pacific Northwest and now in the Southeast United States who's for over 2 decades has made a good business as a self-performing general contractor, whole building repair specialist, repairing buildings that are 7, 6, 5, 4, 3 years old, slowly decladding them, repairing rotten OSB sheathing, repairing rotted rough opening, pulling windows, repairing the rough opening, reinstalling the windows, recladding the building. And what they find when they pull the cladding typically is disintegrated building paper, corroded fasteners, decayed sheathing and structural members, and severely compromised peel and stick flashing membrane. There, as you see around the frame of that window. Well, after doing this for a couple of decades and testifying in over 85 lawsuits as expert witnesses as to the forensic causes of this damage, the remedial measures that would be necessary, and the costs, it occurred to them that they were replacing the same peel and stick and building wrap with more peel and stick and building wrap as they rebuilt these buildings. And they started to get uncomfortable that, as careful as they were, that they might be the next victim, because they realized that $13 million, for example, here in repair funds doesn't just fall out of the sky on this 3-year-old building. It takes a cadre of lawyers, 800-pound consultant like Simpson Gumper, a lawsuit, and a major settlement fund. They didn't want to be the next victim. So they set about to gather together all the building wrap materials and peel and stick materials on the market and test them. And they didn't want to test them to low levels, for example, like we see the energy source standard at 50 pascals or 20 miles an hour. They wanted to test them to something a little better than that, because they found on the 6th story of a condominium in Seattle, they got 105-mile-an-hour wind, 125-mile-an-hour wind during a rainstorm. So they went to the testing companies to see what kind of test rigs they had, and they soon realized that what they were seeing was not going to stand up to that kind of testing. It happened that one of the principals in a prior life was a designer and fabricator of search and rescue vessels for the Coast Guard in the Pacific Northwest. He said, "I'll build me a test chamber." He put that design and fabrication ability to work to do that. He combined a third element, and that is a passion for measurement. Because growing up in a construction family, ever since he was a small boy, he can remember his father telling him straight, plumb, square, and level. And the vendor of all that equipment on there has told us that it's the most highly instrumented facility of its kind in the United States, including the air leakage testing equipment that the automakers use to test their windshields. to perform a wide range of air leakage and water intrusion testing. And they do it on an iterative basis. Test, determine the failure level, determine the location of the failure and the mode of failure. Evaluate materials and methodologies and details. Adjust. Got a 7-by-foot test area on one side, that 17 by 10-foot test area on the other side. You put an entire wall assembly in there for testing. Well, when I went to visit these folks initially, it was like most business trips. Started out with an airplane flight, going to end up with an airplane flight, and I was late for my flight. So I said, well, this is an impressive machine, but I sat on the technical committee of the Air Barrier Association of America. And to pass that regime, you got to show pretty much zero air leakage at 75 pascals of pressure. So if you don't mind, I'd like to just cut to the chase, and would you just please tell me whether these chambers will perform to that standard in these products that you've developed. And the fellow explained to me, he said, you know, we tested everything we could find, and they wouldn't perform in these chambers the way we wanted them to. And that's why we developed these products. He said, because the kind of products we're after and the kind of testing we're doing is not 75 pascals corresponding to 25-mile-an-hour wind. We go to 40 times that, about 2,900 pascals, corresponding to 155-mile-an-hour wind-driven rain, Category 5 hurricane. I looked at my shoes. I said, I think that'll do. Now, how do these guys come up with these products? Well, they employed a process called systems engineering. I'm fairly confident they didn't know they were performing systems engineering when they did it. I just happened to be able to recognize it because I spent 10 years at a U.S. Department of Energy National Research and Development facility operated by Lockheed Martin Corporation, regarded as a champion of systems engineering. That's why we have the very unconventional, highly performing stealth aircraft, totally unlike anything seen before them, that have made such a major contribution to our military. Well, before I tell you what systems engineering is, let me give you a couple of hypothetical examples of what it's not. It is not hypothetically being in the business of manufacturing peel and stick roofing membrane or below grade foundation waterproofing, walking out into your factory one day and seeing all that equipment and personnel and raw materials and say, hey, let's make a WRV for the backup wall out of this. That would not be hypothetically systems engineering. Or if you're in the business of manufacturing spun polyolefin sheet packaging goods for the packaging industry, to walk out into your factory and say, let's make a building ramp out of this stuff. That would not be systems engineering. Systems engineering is not rocket science, even though Lockheed Martin makes rockets. It's pretty simple. You make a list of all the features and functions that that product has to have for optimum constructability and long-term building performance. And then you scour the globe to find the technology with which to implement those functions and features. And that's what these guys did. And that's why, initially, these products were specified by expert waterproofing consultants on coastal properties with up to 3,000 rough openings. Properties of such a high profile with such high profile clientele that failure was not an option. Not exactly your strip shopping centers. Getting quite a bit of traction in residential as well, especially in Florida. Now, one thing you won't find in the specifications for any of those structures, and that is the national standard for the preparation of the window rough opening and the installation of windows. ASTM E2112. You won't find that on those structures. What is ASTM E2112? Purports to be instructions for complete integration of the external wall components, indeed the holy grail of the construction industry. These guys have been doing that expertly for 20 years. So they decided to put together this mock-up and test it. Now, I hope you get the impression that we go to some lengths so that these presentations are not tedious for the audience. Try to have a lot of slides, try to have something interesting to say. And we'll break with that for a minute. Because we like for designers in the audience to think for a moment what you're doing when you ask contractor employees to do painstaking, tedious, difficult, exacting work over and over and over again and do it fast so somebody can make some money. Your less dedicated employees are going to cut corners every time. And even those that are dedicated are going to fall prey to human error. Step 1, install sheet membrane into and below window opening. Step 2, install sheet metal tray. Install sheet membrane into window opening. Install shims. Install window. Install sheet metal head flashing. Install peel and stick from above substrate to head flashing. Building installation paper with drip edge flashing. Building paper installation first layer first row, first layer second row, first layer third row, first layer fourth row, first layer fifth row, second layer first row, second layer second row, second layer third row, second layer fourth row, second layer fifth row, second layer sixth row. Lift second layer fifth row at window to prepare a peel and stick. Install peel and stick as shown. I think that times the number of windows in your structure. So they put that together very painstakingly in strict accordance with ASTM E2112, and then they set about to test it in accordance with the window manufacturer's standard for a 55-mile-an-hour wind-driven range. Now, you all are technical people. You probably don't need to have this explained to you, but I'm not so technical, and I got to orient myself every time I show this slide. What you're looking at is a window installed in the side of the test chamber, and you are standing outside the test chamber. This is as if you are standing inside the building, looking at the inside of the window to see whether the rain's going to come in and get you. Likewise, if you open the door to the test chamber and go inside the test chamber and look at the window, you're looking at the external face of the window where the weather would be. All right. The first thing they do when they conduct this test is they go inside the test chamber and they take clear plastic polyethylene sheeting and they mask off the entire window. I'm motioning here from left to right, clear across the window expanse. Well, now, why do they do that? Because they're concerned that the window is going to leak water into the rough opening. They're afraid that the window is going to leak water into the rough opening. That is not what they're trying to test. They're trying to test the window installation into the rough opening. They're trying to tell if water is going to come from inside the chamber, from outdoors, between the frame of the window and the rough opening to test that ASTM E2112 installation process. Well, if water starts running through the window in the rough opening from a defective window, you're not going to be able to tell where the water's coming from. Well, why should they be concerned about an anomalous result like that? Because it ain't anomalous. After repairing a lot of 3-year-old buildings and pulling out leaking windows, you start to think, I wonder when these windows started leaking. So they instigated a process of testing the windows before they took them off the back of the truck, or as they took them off the back of the truck, before they got them up to the job site. And they find that 20% of them leak. So they send that 20% back, and they get another batch, and 20% of those leak, and they send those back, and then so forth until they get 100% of the windows that don't leak, and then they put them on the project, which is why they haven't been sued yet. So when they do this test, they mess it up. Again, they're looking for water to get between that interface to test that installation. First, they turn on the air. Test chamber is like a balloon. Blow air into it, pressure develops inside there. That pressure replicates the wind. When the wind blows, that's the impact it has on the building unit. Creates air pressure against the building. So they turn the air on. And they turn the water on. Spray rack, water on a building surface plus air pressure equals wind-driven rain. They put in the water a fluorescent dye, which under a black light turns, as you can see, green. And you can see that white frame now is purple. Although some of the ladies in the audience always insist that that's pink. Whatever. What they're looking for is to see whether any green shows up on the outside of the pink or purple, because that means water is getting between the frame and a rough opening, and that the ASTM E2112 87-page national standard has failed. And in 57 seconds, it has failed. And more so, at 5 minutes. Put together in strict accordance with the national standard, tested in accordance with the national standard for testing. You know, I mentioned RCI previously, formerly Roofing Consultant Institute, now doing water intrusion consulting on the whole building envelope. It is no surprise that their monthly technical journal is called Interface, because they know it's at the interfaces of dissimilar materials and similar materials where materials fail and human error causes problems. Now we're back to that mock-up again. I'm going to press this button, and this thing is going to count the number of interfaces in that 21-step process. '74. Was tempted to add to, say something about trombones. You think I was a highly cultured individual. What about ASTM E2112? Obviously difficult to properly install, and when you do properly install it, it leaks. And you know if it's leaking water, passive house, it's leaking air. Well, when I see something like that, I say, now, wait a minute. I would like to see some corroborating evidence. Thank you very much. These guys built the mock-up. These guys built the test chamber. These guys are hustling the products. Is there anybody else that has called into question ASTM E2112? How about a paper that says challenges with using ASTM E2112 in a North American climate zone? Dig further. Some of you may remember Paul Newman, Robert Redford, Butch Cassidy, and the Sundance Kid. And who are those guys? Who wrote that paper? Look into it, a couple of heavy lifter consulting engineering firms, that's it. proceedings was it published in? Building envelopes. Sponsored by whom? National Institute of Building Sciences and ASHRAE. Okay, I might read this paper. Coming out of Oak Ridge National Lab, well-known building research program. What's the paper say? Reliance upon face seal systems, i.e. peel and stick, has a higher risk of water penetration because of the inherent aging of the materials. Remember the photographs where I tore the cladding off and showed you what was behind there. Thus reducing the overall resistance to water penetration and consequent damage. Conclusion. Windows may leak. Guess these guys aren't making that up. Secondary protection of the window opening is required. It's not enough to put peel and stick on the outside and assume that the water's not going to get to the rough opening. And they enumerate, not by way of requirement, but by way of just enumeration, the typical systems for protecting the rough opening in existence at the time that was drafted. They mention that whatever you use, put discontinuities in the sill. Leave a gap. Water accumulates in the sill area because of gravity. Let it get out. Drain down the wall into the flashing system out on the sidewalk. The types that they enumerate, metal, plastic, composite, self-adhered. Frankly, I bet folks in this room and out in the audience know a lot more about the pitfalls of these systems than I do. But let me look at some of the notes I took from this contractor. Metal pan flashing. Standard allows you to either weld the corners or use sealant to glue them together. Don't glue them, doesn't work. Welding's expensive. Then to install them, in the sill area where that pan is, you take a screw and you drill it through the pan into the sill. Well, that's the area that you're trying to introduce continuity. And here you are driving holes in it. Now, you can take your tape measure and measure out a spot on the sill before you put the pan down and put a glob of sealant down and then put the pan down and then measure where that glob is. And I'm sure that's done a lot, and no wonder contractor says that's problematic, getting that to work. And apparently there's an ongoing war between specifiers and framers and window installers about what size that rough opening is going to be and whether the window's going to fit in. When you go sticking a bunch of metal in there, it gets even worse. Costs a lot of money. Custom fabrication requires a high skill level, which unfortunately we're not having as much of as we used to. And I challenge anyone to go to section 5.16.8 and read it any other way to say, if it ever gets cold where you are, don't use metal flashing. What about peel and stick to create this pan flashing in the sill area? Well, to get that to work right, you end up with these folds or tents, agglomerations of material in the corner. So the fellow installing that's all done, and then the window installer comes along and says, "That ain't gonna work," takes out a knife and whacks it out. There goes your waterproofing and your air leakage protection. What's left has bridges, fish mouths, and importantly, that material is vapor barrier material. Take a towel, hang it out on the line, it'll dry. My mother taught me that. Take a towel, sopping wet, put it in a garbage bag, seal it up, hang it out on the line, come back in 2 weeks, it'll be sopping wet. That's what a vapor barrier does for you. Put a vapor barrier on OSB that gets wetted during construction, because guess what? It rains during construction. About half the damage these guys see comes from rot, from the failure to dry. The other half from water intrusion. Well, how do you make a pan flashing in the sill area out of peel and stick material? A little cartoon for that. A little training unit that these guys used to use. cutting, and folding, folding and cutting, cutting and folding. You know, every Christmas, I buy my wife a piece of jewelry, and I go to the Hallmark store and I get a pretty bag, and I put the little jewelry box in the bag, and I get the lady to sell me some tissue, and she always wants some of that whole package and yells at me because I only want 2 sheets. I poke the sheets down in there, and I put a card in there, and I put it under the tree. But I gave up on wrapping Christmas packages a long time ago. This is way above my pay grade here. Imagine doing that over and over. And so forth with the 21 steps and 74 interfaces. Contrast that with a fluid applied system. Gun it out of the cartridge, knock it down with this high-tech piece of equipment here. Looks like it's called a Bondo blade. Looks like something you would knock the frost off your windshield with. Come along with a joint and seam filling material. Come along with the same chemistry optimized for waterproofing. Gun it down, knock it down. You're done. No 21 steps. No 74 interfaces. The most vulnerable part of the building envelope, where 98% of the leakage occurs and the problems develop, is now a waterproof box. Come along with your spray applied or roller applied WRV/air barrier coating on the field of the wall. Again, you have no seams to tape, no lapping to worry about, no fasteners, penetrations. Now, this shows a CMU wall. It's the same thing for a stud construction, a sheathing wall. You're standing inside the building now. You see the red waterproof box. The window's been placed in it. Take a conventional sealant formulation of that same STPE chemistry that formed that waterproof box, put an interior air and water seal around the interior perimeter of that window. This system's designed on the assumption that the window leaks. I wonder why that would be designed that way. So, if any water gets forced into the rough opening from the sheathing wall, or if the window leaks into the rough opening, the water hits waterproofing material, the red material. If there's a lot of it, it backs up against the front side of that waterproofing sealant and it goes out. The discontinuities or weeps that we showed in the still area. Through-wall flashing the material, when contractors and specifiers, designers see this material, they think of all kinds of applications. Some of the ones that are more typical are the installation of the through-wall flashing at the base of the wall, this metal flashing here. Take a bead with a joint seam filler, fill that critical material to backstop this material. Take a bead of the joint and seam filler over the turn bar on the top, counter flash it with the red waterproofing material. Same way with through-wall flashing in the spandrel condition. Here's some photographs, just to give you a quick idea that this is all about as easy as it looks in graphic form. Here the pink joint seam material has been gunned out and knocked down. Now they're coming back over it 10 or 15 minutes later with the material optimized for waterproofing. This is a mock-up. In fact, we've got one here with us. This is an example of what it can look like out on the job site. It doesn't have to be pretty. Here out on the field of the wall, below the sill area, and to the right of the rough opening, we've got a WRV or air barrier of the same chemistry that's rolled on. CMU is about the same, except you have really no joints or seams in the rough opening, but we do take the joint and seam filler in the corners because we tend to have some cracking of the CMU under there, so proactively deal with that. And come across with the waterproofing material, again rolling on the WRV/air barrier. Look how that pipe penetration has been detailed with the pink joint and seam material. Try to do that with peel and stick. Here, this is photographs of the through-wall flashing being installed. You can use the material as an adhesive. STPE is probably the most widely used adhesive internationally. It's used extensively in the trucking industry, in the RV industry, where they have a lot of dissimilar materials they want to hook together, weld together, and have them move a lot. So, STPE, liquid pan and rough opening flashing, becoming commonly specified, and the second shift during the recession. It has been recognized in the architectural record as among the top waterproofing products of 2010, and it's entering the ASTM process. I sit on the committee for ASTM 2012. Here's the photographs of that interior air and water seal I talked about. And again, you look for corroboration. Go out on the internet. Put in interior air seal. You'll find this blog. We encourage installers and builders to take a second look at the potential advantages offered by installing an interior air seal. Who is this guy? I understand he's been around for a long time, very highly respected in his field. And the window manufacturers. Apparently these guys are a little ahead of their time, because now the window manufacturers say, guess what? Use Baccarat, as this system uses too, and sealant around the interior perimeter of the window. All right, earlier in the presentation I said I'd come back to the chemistry a little bit, and we won't dwell on this too long. Now suppose when the Japanese come over here and they see the different means we have to communicate with each other, they might be a little bit taken aback, as you might be looking at this graphic that they put together. But what they're trying to say here is that the green material, which is the STPE, has the initial MS here because this is sometimes referred to as modified silicone, that it bounds the blue silicone and the red polyurethane, bounds it, outperforms it in terms of performance on a number of different factors, as much as we saw in that table previously. And likewise with workability. Now, a little closer to home, here is a paper by the author of the McGraw-Hill Adhesives and Sealants Handbook. Here's his resume. The paper he put together, and that was published by the Adhesives and Sealants Council, and there's that graph again. That table that I showed you earlier that hopefully now has a little better context. And here's a couple of blurbs from vendors of the sealant resin, saying in their own sort of complicated way that the product is readily amenable to being used as a coating. Now, specifiers seeing this kind of performance say, what is this going to do to the cost of my project? Well, that all has to do with the contractor and who bids it. So we don't get into labor here. I'll give you some material costs. Before I do that, I want to give you a data point, and that is all over the country, contractors are going to their specifiers on ongoing projects and begging that these materials be substituted for peel and stick and building wrap. Contractors don't go make requests so that they can increase the cost of their project. They know they can make money using this. One of them, for example, does a lot of dormitories in Alabama, says he can do 3 or 4 windows with this material. For every one, he has to peel and stick. For the rough opening, where you use the joint and seam filling material and the waterproofing material in tandem, you're looking at about $1.18 per linear foot. To use the high-performing STPE air barrier out on the field of the wall, you're looking at about 80 cents a square foot. There are also available acrylic emulsion products that have been approved by the International Code Council Evaluation Service as water-resistant barrier substitute for building wrap. Not quite as waterproof, but that are sprayable rather than rollable, and are somewhat less expensive. Well, I'm going to close up now with a couple of case studies. The first one is a remediation situation. This involved an It says assisted living facility, but this is a full-blown elder care facility. It occupies an entire city block in a major city in Iowa, such as Iowa has major city. But it's everything from assisted living all up to full-blown nursing home care. This particular project involved these balconies. The photograph in the lower left-hand side, you can see that balcony there, middle of the photograph to the left. Predictably, the slab forming that balcony floor was pitched to the outside so that rain falling on it will drain off the edge of the slab. Unfortunately, it was also pitched over toward that column on the far left, which is a wooden post with sheathing and siding. So the building owner's rep saw that, kind of consultant fellow, and he said, "Man, I'm not liking the look of this." He says, on the far left, when it's raining, the water is running right against that sheathing, and the sheathing's taking up that water. And then when the rain is over, the slab is saturated, the sheathing's taking up water by capillary action, sucking the water out of the slab, further damaging itself. And not only that, on down on the edge of the slab, he says the water is running behind that sheathing and wetting out that whole area of the wall assembly. He said, "That's no good, Mr. General Contractor. I want you to come in here on all these 100 balconies and use some sheet metal, custom fabricated. And by the way, it wasn't going to be exactly the same one for each unit. And I want you to fix that." You can see the connection there. So I had just been introduced to this product my company had. I was in that major city with this white shirt, tie, and suspenders rig that I wear when I give presentations. So I showed up on the job site with the GC, who was not happy to begin with and less happy when he saw me. And I didn't know what to do. I had an iPhone. So I took some photographs and I emailed them back to the consultant we have on staff. It's a former waterproofing consultant with one of the major consultants, also a major player in the development of these products. I said, "What do I do?" He printed them out, as he does, printed them out, marked them up, emailed them back to me, called me back, put the iPhone on speaker. We had ourselves a job site meeting between Iowa and Florida. He said, "You got to disconnect that sheathing from that slab, far left corner. Cut that out." He said, "Then you got to take that siding off the face of the slab and cut that sheathing out." And they told us how we would proceed then to use the products that I'll talk about. But I want to talk for a minute, backing up here, about that siding that's on the face of that slab. If the general contractor had a problem before he showed up there, he had a bigger problem when that siding got popped off. Very awkward, silent moment. Because that happened to be where there was a lap in the underlying building paper. I told you to put that in there in a shingle fashion, top over the bottom. Because it was reverse flashed. Now, for a long time, I could never remember what reverse flash meant. And every time we'd be in a meeting at my company and someone would mention it, I would sort of cringe silently, hope no one would ask me to explain what it was. And the president of our country, being a sensitive company, being a sensitive individual, trained as an architect and our technical director for 18 years, became irritated with me one day, noticing that I was cringing about not knowing what reverse flashing was. He said, "Paul, just remember this. You don't want to stick your raincoat in your underwear." And hence I have never forgotten what reverse flashing is. It means you have taken the upper course of material and stuck it behind the lower course, which means, if I get this right, you started at the top instead of the bottom. You got to start at the bottom and work to the top. And it's not just on that 18 inches of column. because this contractor I've been talking about all through this presentation tells us that a full third of the damaged buildings that he repairs are reverse flash. And he says, you see it on 18 inches? The whole city block of complex is reverse flash because they don't change their ways. Another good reason to have a fluid applied system. Don't have any lapse for reverse flash. It's impossible. All right, the GC brought with him a subcontractor who'd never been on a project before, never seen the products before. I didn't want to work with him, so I handed it to him. The instructions we got were to take the joint seam filling material and put it, guess where? On the joints of the seams, far left-hand side. It doesn't go on the edge of the slab because guess what? There's no joint or seam there. Then take the waterproofing material, go over the joint seam material and exposed slab, bring it out, center photograph down, bring it out onto the edge of that siding, create sort of a liquid drip edge there. Long story short, the building owner's consultant, who had hired a waterproofing consultant in Florida, saw these photographs, and I heard 2 weeks later that the entire project is being done up this way. By the time we were leaving that day, the GC was looking a lot more friendly because he saw that he's just going to save a whole lot of money, time, and trouble compared to the metal treatment. And like I said, the project went ahead and used it. Here's another example. This is a renovation. What they're going to do here, you'll see at the top of this window, these are those old-timey windows like they had when I was in junior high school with the ropes on them. The plan here is to use the window frame as a rough opening for the installation of new windows. Okay, fine. However, this is a slide I use for internal trading. If someone tells you that their peel and stick waterproofing membrane or sheet wrap or whatever is going to bridge over some airspace, like a piece of plywood is supposed to, and provide structure to your building, ask them what they're smoking. Because no waterproofing material, sheet good, peel and stick, fluid applied, provides structure. It goes on structure. It waterproofs structure. It don't create structure. So if you've got a hole big enough that shows a lack of structure, you got to put something in there. I had a situation at a soccer stadium that went in Kansas City. He took me out on the job site and they showed me a space where between the door opening and the next stud, there was about 3 inches. And the sheathing was on the stud, about a 3-inch hole there. How do I waterproof that? Put a wall in there. All right. So what were they left with? Well, look at all the stair steppings you got to get from the inside to the outside. How are you going to do that with peel and stick? Here, I counted them and pointed them out for you. You've got to bend and fold and press and stick that material and try to get it to go all those places. Impossible. Joint seam filling material, you gun it out, knock it down. Go back over it with the waterproofing material, gun it out, knock it down. And that's all she wrote. Now, it's Saturday, and I appreciate you all coming out. I got a plane ride ahead of me later on this afternoon, so I'm not in a hurry, but the first thing I want to do is get out of the spotlight, sit down, and not be under all this stress. However, what I find is as soon as I do that, the hands shoot up. Now, some of you look like you're young enough, you might be childbearing age, and if you go to parenting class, you will hear these days that it is inappropriate to count to 5 with your children. They don't allow that anymore. But it works great with architects and contractors. So, I'm going to count to 5. You got to gird up your courage. You're going to ask a question, you're going to have to ask it now. And then I'm going to sit down and I'm going to be unavailable. Yes, sir.
Permeability.
Permeability is an absolute must. If you go to our website, you'll see that we do sell a vapor barrier, only because the president and I caved in after years of pressure to our sales force, because there are some specifiers out there that just insist. Vapor permeable is what you want, and what everything I'm showing you here is, and everything on this mock-up except the little bitty corner here on this back side is vapor permeable. Extremely important. Avoids condensation in the wintertime, allows water vapor to get out of the building, and allows drying. Remember the garbage sack and the towel. Next question.
What's the perm rating?
Perm rating. I'm turning this mock-up around, and I'm doing this by memory. And so you can find a little different number maybe on a product data sheet, but in rough terms.
Hang on a second, Paul. Do you want me to put on the camera?
Well, if you can, yeah.
Let me see.
Oh, actually, no, I don't think we have that outside.
All right. Well, basically, the pink material that was in the slide, the joint seam filling material is 14 perms. The red waterproofing material is 14 perms. The brown roll-on WRB is 17 perms. Then we have an assortment of acrylic emulsion spray-on WRBs. The top one here is 17 perms. The middle one is 10.5. And then the vapor barrier one that I prefer people not use is 0. Yeah.
Can you use it in foundations?
We do not market it or support it for foundations. We think it would probably work pretty well, but we're just not going there. There's cheap, low-cost commodity products that are suitable for that. Fish earth up against them and never see them again. Sir?
Nails and screws through the membrane, through the application.
Right. There's a test called the nail sealability test, ASTM-D as in dog, 1970. All the products have passed that. The STPE products, we take a step further, and or can be taken a step further. If you get up here and start pressing on this material, you'll see it has a certain sponginess and a certain tackiness, even after it's cured. The sponginess gives you a mechanical bond against the fastener, squishes against it. The tackiness indicates that it actually chemically bonds or glues itself to the fastener. So on the test chamber that we hauled around to 50 cities and gave a 2-hour version of this, we had some of the fasteners that were drilled through the coating, through this gypsum board, dense glass external gyp board. For those not familiar with it, just like drywall, it has a fiberglass mat on it for some temporary water resistance during construction. But we had it, the screw screwed through the coating, through the gyp board, intentionally missing any stud, interrupted in the penetration by 1/2. In other words, we only screwed it halfway in, so it had the shank exposed without the benefit of the head sealing against the coating. And turned up the pressure to 155-mile-an-hour wind-driven rain for 2 hours, and then I would take architects around to the back and show on that gyp board with a screw dangling in it, in that powdery gyp, and not a drop of water coming through it. And we got a lot of specifications out of it. Yeah.
Well, what's the expected lifespan in terms of degradation? You know, you said the other things failed and degraded.
Right. 3 answers on that. One, the material first was used in 2004 and 2009. This contractor sent a forensic architectural investigation firm into the building where it was first used and deconstructed the building and did a complete evaluation. I can give you the report. After 5 years, they found no water, no physical change in the material or its properties. The manufacturer of the resin, originally in Japan, has conducted studies to find that when it's used externally, that means pounded with UV, which is, of course, the main degradation factor for any steel undercoating, even after 10 years, there's no change in the mechanical properties. Basically, and of course, this material never sees any UV after the first 6 months of construction, which doesn't touch it at all in terms of UV. It's covered up by cladding. So we view it as a life of the building material. Certainly, it's not a maintenance material where you're going to have to deconstruct the building and replace it. Yeah,
The drastic drop on ACH levels, did that apply also to all masonry buildings? Did that apply across the board? Have you tested all masonry systems?
it does apply across the board. And basically you get the same result. We haven't put CMU into our hurricane chamber yet because it's a weight factor in constructing a wall. But I have tested CMU with this much less robust coatings that I mentioned, and they easily pass the standard. Frankly, the standard is so low, and the test doesn't rack or anything. It's a static wall, and that it doesn't take an extremely robust coating to pass it. With the roll-on material on sheathing, we have a racking device, which is basically a big hole cut in the sheathing, and then that hole is reduced. The donut hole that you take out, right? The piece you take out of the hole is then reduced in size by a ½ inch all around, and we caulk that in with the air sealing material that goes around the window and coat over the face of it, and then we turn on the machine to the hurricane standard, and then we rack it like a parallelogram and all kinds of ways to make it go to 0 at the top and 1/2 or whatever at the bottom, and likewise, and really put the whole thing under a lot of pressure. A CMU wall, you would never see that, and it passes that.
How does it react with like XPS or polyiso? I know I was reading where there were some reactions with certain products that affect that foam. How does this?
It's compatible with everything that we've tested, all the foams.
What are the basic chemical components? I mean, I know you can't give away formulas, but what kind of polymers or materials are you using? And I guess the associated question with this is there off-gassing or any kind of chemical exposure risk for occupants or workers?
Sure. The predominant material within the mixture is STPE resin, sealant resin. As far as what else is in there, they don't even tell me because then you have to kill me. And one thing I can tell you is that it passes the South Coast California Air Quality Management District volatile organic compound regulations, which essentially say you don't have it. And then that in turn is incorporated by the LEED standard. LEED doesn't apply to materials except used on an wall face, but a lot of specifiers like to extend it out to any liquid materials being used in the wall assembly, and these pass that.
How do you control the thickness when you're
It's a good question. He says he recognizes that getting an appropriate thickness is important, and how do you control that? And sort of the following question, or embedded question, is how do you monitor it? One, with the color coding, you get monitoring to know what's been put where and when. And consultants find that very useful. But as far as the thickness, the material is not opaque unless it's thick enough, which means if you can see the substrate underneath it, through it, then it ain't thick enough. Been designed for that purpose. Yeah.
What's the dry time?
Dry time is a really long time, but that's not important because you remember I said a moment ago the material seems to have a residual tackiness, and so that it still is chemically active and bonds to those screws. We want it to have a long dry time. So I'm kind of picking nits with you a little bit. It's an important and difficult question. It takes a long time for it to ever lose that tackiness. We want it to remain chemically active during the construction process. As far as how much time has to expire before you can take the next step, that's what most people are concerned about in terms of dry time. For the pink material, in terms of how long you have to wait before you can go over it with the red material that goes over it, is between 10 and 20 minutes depending on heat and humidity. The material is moisture cured. The more humid it is, the faster it cures. And so in this state, as opposed to Arizona, you're going to get some pretty rapid drying or preliminary curing. Does that respond?
Yeah, so like in application, it doesn't dry up on you as you're installing it, unless it's a really hot humid day.
Right, even then, you're not going to have it become unworkable. It's going to remain workable for at least 10 minutes under the most hot humid conditions. It's going to be good and workable for at least 10 minutes.
Is that enough time then when
Yeah.
you're doing an entire?
Yeah, normally what they do, they put one person to work installing the pink material, and then they'll have the person come behind them with the red. And, one guy waits 5 or 10 minutes before he starts, and then they're just staggered like that, and they go to town.
I think you already answered this, but where you have joints and they're moving relative to one another, material I gather is satisfactory. It's got enough
Yes, it has elongation.
elongation.
Yeah.
I came in a little bit late for the presentation, and I don't know if I missed this, but what's the detail for the nailing thing? You got it over the pan, you got it over the barrier.
Right, that's a good question. It's asking about the detail for the nailing fin. First, let me explain how I explained the system to your colleagues here, and then I'll address specifically the nailing fin. First, you turn the rough open, before you cut the window in, you turn the rough opening into a waterproof box with the products.
It's not that hard.
Then you set the window in the waterproof box. You take some backer rod, go around the perimeter to form a backstop to hold the sealant you're going to put in. This is a conventional sealant formulation of the same chemistry, so it bonds tenaciously to this red material. You put an interior air and water sealant. All right. The contractor that developed or co-developed these products at that point is done. He doesn't do anything else because the system is designed on the assumption that not only can water potentially blow up here into the sill area or through this flange and get up into the rough opening, but it's also designed on the assumption that the window is actually going to leak water into the rough opening. It's designed so that any water that gets into this rough opening hits waterproofing material, this air and water sealant back here, hits waterproofing material here and can only go one place, which is out the sill.
Drains back out.
Right. Now, architects say, well, I see the theory of it, and I'm glad it works in your hurricane chamber, and I'm glad that contractor has rebuilt hundreds of buildings this way, and he's satisfied. But I'd be a lot more comfortable if you would take that red material and counterflash over the outside edge of that flange. And we say, we'll sell more product. So knock yourself out. It's totally unnecessary, but we support it if you want.
Now what if you lay polyiso or XPS over the top of this? So now you got it's laying over the top of this like that, and drain down and get the polyiso.
Well, you're outside my pay grade, but I got a guy that can answer it for you.
And one could argue that you want the sill to be open just so that it'll drain freely. You certainly don't want to cover up the bottom.
Right.
And wouldn't we feel more comfortable if there was a sloped sill or a back dam that's sort of built in?
One, that complicates the window installation, and two, when I give these presentations, they're often in very fancy hotel auditoriums with white tablecloths and these big jugs of ice water in front of every architect. And when they ask that question, I take one of the jugs of ice water and I hold it on the table above them and say, do you need me to demonstrate what happens when you pour water on a flat surface? And they all withdraw the question. Next question.
Temperature restrictions, winter versus summer, shady
Really
side
no
of the
upper
building.
end, really no upper end on the temperature, especially here, Arizona, 130 degrees or whatever. We might have some precautions. As far as low temperature, it will not commence the curing process below about 33 or 35 degrees. If you put it on when it's cold like that, it will not harm the material, and it will apply. down to some level, I suppose. You know, we haven't gone there. But on those marginal levels, it will apply, and then it just won't cure until the temperature gets up in the high 30s. This
Suitability for roofs or decks over heated space.
Like I said during the presentation, when designers and contractors see the material, they instantly gravitate toward what I call unauthorized uses. One of the uses that we are on the cusp of authorizing are the ones that you described. There are some examples where it's actually been used for that. In fact, there's an example where it's been used as a roof underlayment for a metal roof on an enormous facility in the Pacific Northwest. But you will not see that in our product data sheet, which means that we will be liable for you doing that. However, if you would like to engage us to support the product that way, I would recommend that you get in touch with us, and we might be able to work out a special letter exception to the data sheet that would support whatever use you have in mind. Sir?
Just in terms of siding materials that are then available, everything can go over the top of it?
Uh-huh.
Any stucco, I guess?
It was designed for use with stucco initially. Yeah.
Okay. Rain screen applications? Is it the idea that you leave a breathable space behind the siding and you install it on frame?
Right. I was talking to rain screen people at the AIA show here in DC yesterday, where we had a booth, and I was walking around looking at all the technologies because I get questions like this. And the response was, yeah, our material, the rain screen, would go directly over your WRV.
And so, does that get any UV exposure? I mean, I'm always curious with rain screens. You know,
Well, I'm going to pick nits with you a little bit. What I am finding is that when people refer to rain screens, they can be referring to one of two distinctly different things. There's one use of rain screen, which is a matte type material that you can actually see through, that goes on the backup wall over the WRV and behind the siding or brick cladding that forms a gap that assures that there's a good gap between the siding and the backup wall for airflow, for drying, and for water management. Some people refer to that matting material as a rain screen. Other people refer to a rain screen assembly as one in which there may or may not be that matting material, let's say there isn't, and the cladding is not conventional cladding that is continuous like a brick wall or siding, but rather it is made up of discontinuities, significant areas of openness. Or in the case of metal panel rain screens, you'll have about a 1/8 inch, what I call a slit, around the perimeter of the panels. Those rain screens raise what we call a UV issue because, theoretically anyway, some sun can get in those slits and access the WRV behind it. Of the WRVs I've shown on this mock-up, there is one which we authorized for use with rain screens that expose the WRV to UV post-construction, and that is the roll-on STPE material. It's very robust. Did I respond to your question?
Yes, sir. Can you apply these to damp surfaces in the rough opening?
That's critical. You can apply them to damp surfaces, even wet ones, as long as there's not running water on them, and they can be rained on 3 seconds after they come out of the tube. In fact, when we physically demonstrate these, we have a wet water bottle that we gun the material out, knock it down with the blade instantly, shower it with water, and it's has no impact. Sir?
Can be used for like non-rigid penetrations like wiring, something that might flex a little more to like a box or a main trunk line coming in.
Wiring without conduit?
Yeah.
as long as you can get the material around it. I said, do we have a protrusion in here? I'm not seeing one on this. Well, here we go. Yeah, I think if you come up later and take a look at this, I think you can see that as long as you can make contact with whatever it is you're trying to detail, you're going to detail it. Yeah, that's one of the big pluses for it.
How about on just pure surface volume? I mean, does this become impractical when you're dealing with that? It's the first thing that came to mind is like I put on a lot of coffee, you know.
Right.
Only.
Yeah. Question is, from a constructability and labor and practicality of using a caulk gun, it looks like you might end up using quite a bit of this material on a significant structure, and that just seems like a lot of trigger pulling on a caulk gun. There are a couple approaches to that. One is there are caulk guns that, as I understand it, are energized in some fashion. And the other one is called a bulk gun. And you can get this cartridge material, at least the red waterproofing material that you use at higher volume, you can get it in a 5-gallon plate with a follower, 5-gallon pail with a follower plate and a hole in the middle. And you stick the nozzle of your caulk gun in there and pull it out so you're not switching tubes. But as far as having to squish so much, I guess that the power assisted gun would probably be the thing. I know the contractor that uses this and basically invented it or co-invented it and uses it extensively. I know they just use a regular caulk gun or a bolt gun. I haven't heard about them using a power unit.
Okay, any other questions? One more?
Yeah. What about if you get it on something that you don't want to get it on and want to clean it off?
You want to carry some rubbing alcohol with you.
That's the preferred.
Yeah.
Is that it? Rubbing alcohol?
You get it on your hands or anything like that? Is there any?
I don't like to wear gloves, and I'm sloppy, and I was using it once and got it all over my hands, and I thought I had that pink stuff all over it, so I went to car wash. I thought, that'll get it off. So I took the nozzle on soap foam, and I pressed it on there, and I thought, well, this is interesting. It's actually turning the pink material a kind of a dark red. Whereupon I realized that it was my blood coming through the skin. So you'll want to take some rubbing alcohol with you to have it available. Now, if it's still wet, it'll just smear off. You can just wipe it off with a towel.
I'd like to say around that pipe, if somebody took their finger and smeared, get it on there.
Yeah, you want to keep a rag. I mean, I got a pair of overalls that all multicolored.
Like that, yeah. Guys are going to do that. Yeah.
All right, so I think we've had you here for over an hour now.
All right.
Well over an hour. If we could take one more question, if there are any. Otherwise, I think we can wrap it up. And those of you who are members of our chapter, I'd like to ask a few questions, make a few comments. But as for this presentation, are we ready to close down? Anyone?
The 800 number is beyond good in that compared to all other manufacturers of construction products, we actually have a warm-bodied human that will talk to you instantly. You can call that number. Ask for customer care, and they will talk to you post-haste. Locally, we have our field representative, Ken Houck. He's got his business card up here, and he would be your local man for job site support and other questions.
What's the name of the person I talked to for that window detail?
Get with me afterwards.
All right.
Yeah.
Okay. Thank you very much, Paul.
Sure.
It's been very informative and helpful. And thank you to those of you who attended via the webinar, and we will be hosting